This is Breaking Down Security, and I am Brian Brake. Welcome back, listener. This is Brian, Miss Berlin, and Mr. Betcher for Breaking Down Security.
Yes, it is.
Hello.
Yes, very busy week with everybody coming back from Hacker Summer Camp. I didn't go, and Mr. Betcher wasn't cool this year. He didn't get to go either. But Miss Berlin did, and our guest did too.
Yes.
Yes,
I did.
That is the voice of somebody I just realized before we started recording, and I've been following her since I pretty much joined Twitter. She goes by @SelenaKyle on Twitter, but this is Allie Miller. So welcome to the show.
Thank you. Nice to be here.
Yes. So we were talking about the Hacker Summer Camp. So you spoke at Bsides, which I just made the connection because you said, yeah, I gave this talk at Bsides last week. And I was like, oh, yeah, that's great. And I was like, did you go to Hacker Summer Camp? And you're like, yeah, I did.
It's kind of awkward.
Yeah. Well, sometimes, maybe Bsides is considered like pre-camp. I'm not sure.
Yeah.
Right. But yeah, I went to Bsides. I had a really great time, and the organizers pulled off a really great event. And it was my honor and privilege to give the opening keynote
Very nice.
For Bsides Las Vegas. So I sort of, long-time listener, first-time speaker, and I got to share some of the things that I've been thinking about related to economics in information security, and also touch on my favorite sort of decision science and machine learning type topics. But it was a good time. Yeah. We missed you.
You can say, that's nice of you to say. It's nice of you to say. But yeah, I want to go, but it's the crowd thing. So I heard that DEF CON was just crazy huge, and I'm not one for crowds. So
you're agoraphobic?
I'm a crowdophobic, I think. We actually got into a thing on Twitter about Quiet Con where we could all go and be away from the noise and stuff. And I was like,
I had several conversations this week of people that want to do like there was already a Nauticon, but like a anti-con where there's no loud music. There's just lots of seating, lots of open space, water, pop, and appetizers.
Nice.
And that's it. There's like a cap at the door. You can only have so many people, so it doesn't get too crowded. And yes.
Cones of silence for everybody. Yeah.
Yes.
Cone of silence for everybody. Yeah. Yeah. Cool. So we wanted Miss Miller on to discuss something that a lot of people deal with on a regular basis. Every time you talk to, whether it be endpoint solution or the traditional antivirus folks or, Splunk people, they're always talking about this machine learning and this artificial intelligence. Now, when I grew up, artificial intelligence was data on the enterprise, or, R2D2 if you swing that way. Nowadays, it seems more like it's marketing hype where people are just latching this on to something that doesn't really mean what most people would think it means. So I wanted to have Miss Miller on to discuss what machine learning is and what artificial intelligence is. So Miss Miller, if you could, in your own words, tell me or tell us what machine learning means to you.
Well, I think sort of, as you say, what is meant by machine learning kind of depends on who you ask. I kind of learned a lot of these things on the job working in fraud analytics. And I thought I was working with folks who described themselves as statisticians, right? Or data analysts.
Okay.
And so these were folks who were doing behavioral analytics, and they were using models. They primarily use sort of statistically driven models. But there's kind of a range of things. So I think of things like regression analysis as being statistics. And then they sort of range through to, Bayesian classifiers, sort of different types of classification methods, all the way over to things that are like neural nets. So neural nets were the new hotness in the 80s. And they're back, and they're called deep learning now, essentially. Right. I paraphrase. Okay. I bother some of my fellow data scientists by saying machine learning is the new name for statistics. But essentially, all of these are just different algorithmic techniques for getting the computer to make a sophisticated and accurate decision instead of making a human do it. I think that's kind of how I think about it. So a lot of the systems that I've worked on, there are classifiers that are trying to answer a yes or no question. Is this a fraud transaction? Is this the real account owner trying to log in? Is this piece of software behaving like malware? But then on the other end, where you see a lot of activity happening, are things that are more advanced versions of clustering techniques, right? They're figuring out this group of activities or this group of accounts or this group of pieces of software. They're similar. And we've seen some really exciting advances in applying things like deep learning to classifying and grouping and sort of having additional intelligence around things like identifying images, which is a hard problem. And you can sort of imagine there are similar problems in security that would be where techniques where you can sort of group things together into similar-ish things is useful for us. It's kind of like anomaly detection on steroids.
Okay, so you said image detection. Is that determining that? Is that having to deal with like when you're searching for a chair or a picture of a chair? There's algorithms that will say, okay, this picture actually has a chair in it, or this is the picture of a chair versus one that looks like a picture of a bird.
Yes, exactly. So the easiest way to understand it as a consumer is when you're running a search. When you're running an image search, some systems benefit from having humans help with the classification, but deep learning is just doing some really interesting things where they're essentially using the computer to figure out things are similar. And then there's just weird applications, like I can't remember the name of it, but that one where the algorithms are essentially constructing images. Do you know what I'm talking about? You've sort of seen some. They make some good memes, some terrifying, scary memes.
Yeah, it looks really psychedelic.
Yeah, exactly. So there's different types of applications. I'm guessing that like many of these technologies, our friends in finance and the stock market are going to juice it as much as they can to get an advantage around trading strategies, which is where a lot of these sort of algorithms really get their muscles flexed. And then also just sort of in science and healthcare, anything that can be done to sort of speed up the discovery process by leveraging computers to do learning or simulations will be popular. And then, finally, it will end up enabling ever more powerful detection technologies and security. Okay. And where I sort of feel like we find ourselves right now is there are a lot of practicing data scientists in the world. And they have historically been applying their brain power to things like behavioral analytics, either in marketing or fraud detection. And we're starting to pull them into security. But a lot of those techniques that you need to know to do good data science, which is kind of a combination of programming and analytics/statistics, it's easier for us to consume them as security folks in tools. And so every vendor is kind of like taking out their salt shaker of magic pixie machine learning dust. Oh, that's sort of a weird motion on the screen. But they're sort of taking that out and they're trying to embed it into all of their products. So it is both real, a useful technology that is becoming more sophisticated and useful, and a marketing buzzword.
Okay. Very nice.
So that was
and the latter more important. But I see it as, okay, let's take the issue of fraud, right? The system didn't detect this fraud, so I know from investigating this particular case that it was fraud, so I mark it as fraud, and then the program changes its algorithm a little bit to make sure that that particular thing in hindsight would have crossed the threshold into fraud. Does that kind of summarize it?
That is absolutely where we want to be going with detection technologies. But I think of what you're describing as being slightly different. So machine learning is really the algorithmic approach to teaching a computer how to do some sort of classification. But what you're describing, that feedback loop where you keep taking notes, if you will, on what's happened and pushing that back and retraining those classifiers to keep them up to date and make improvements and incorporate new information when you get it. That feedback loop, to me, is the most important piece in a lot of our detection systems. But that is typically not the machine learning itself. Usually when folks are referring to machine learning, they're referring to the algorithm that comes out of a training.
A training.
Mm-hmm.
Is that like the initial setup?
Training.
Yeah, so you can think of so the sort of process for building one of these models or classifiers is you have some ground truth. With fraud transactions, it would be, here's a set of 80,000 good transactions, 2,000 bad transactions, and all of these characteristics, which may be called features or variables or parameters or signals, depending on who you talk to, but all these things about them, and we're going to plug it into some kind of, maybe it's a statistical process, or maybe it's more unstructured form. Well, actually, I guess it would still be considered structured, but a more like approaching AI type of classifier. And you train it to be good at differentiating your case A, good transactions, from your case B, which is bad transactions. So it's called a training process. That's you train something. So, but then in a lot of security use cases, especially ones affecting end users, because those are things that happen at scale, spam, account hijacking, fraud, malware detection, understanding phishing's going on, those types of things. You need to make sure that then after you get some additional activity, you keep track of what happened in those two, and then you retrain the model. Because as soon as you have some sort of algorithm trying to detect bad behavior, it turns out that the bad behavior will shift, because the bad guys will stop doing the things that get blocked, and they will start doing the things that are missed and get through. So when you're dealing with adversarial scenarios, that retraining loop becomes very critical. But I call that building a learning system. And in a lot of environments that I've been in, that learning system, you have to build it and you kind of have to maintain it forever.
Yeah.
And I don't buy a lot of tools. It just turns out that I've worked in a lot of environments where I've had to kind of work with my engineering teams and analysts to build our own systems and environment, very highly customized.
Yeah.
And so what I don't know, and maybe you guys know about the vendor tools, is how the machine learning gets updated. That's the kind of thing that you might want to ask. With some vendors, they will provide updates, and that's part of their service. And then there may be other vendors where you can customize it to your own environment, and that kind of puts the onus on the internal teams to be keeping track and figure out how to update the thing. So with antivirus, for example, or what it's called now, right? Endpoint.
Endpoint, yeah.
Detection and response.
Then you can forward samples. If you find something that the vendor hasn't found, you can forward it to them. But generally, you're kind of waiting for them to provide updates and additional protection, versus something like a lot of network intrusion detection that I've worked on in the past is that they actually give you the ability to kind of set your own baseline and create your own custom rules.
Okay.
But then that requires analyst work, like analytics analyst work, in addition to kind of operating and responding to potential events.
Okay.
The two things I can think of that I've worked with usually use both. So one is Carbon Black. I mean, they provide regular updates and watch lists and rules and stuff like that. But then you also have analysts that have to constantly train it to whatever's going on in your environment. And then there's also Splunk UBA, which is user behavior analytics, that kind of does the same thing. It's all magic.
Splunk and Carbon Black are not sponsors of the podcast, by the way. So do not take that as an endorsement of either product.
They're very popular. They have brand recognition. So what have you guys been seeing? I'm sort of curious. Is there new expertise required within security, do you think? Or are we sort of pushing back and getting the right capabilities built into these tools so that we don't have to necessarily have new and specific and exotic skill sets that we didn't have before?
Mr. Betcher?
I don't know. I noticed that Amazon had their AI service just come out a couple days ago. At least I got notice of that. So I think that opens the door for a lot of small businesses that don't have a lot of capital to get into this AI type thing, whatever it may be. I don't know much about it currently, but who knows? I've talked to people who said AI is just a marketing scam, and it's not really artificial intelligence, right? Or machine learning. It's just all algorithms underneath anyway.
So
I'm not
right?
sure. What's that?
Yeah. So I'll just put in a plug for TensorFlow too, as long as you're mentioning the Amazon AI service. TensorFlow has been popular. It's got some public frameworks and good uptake. It's a deep learning framework. So, and I've seen some cool applications on it related to some of the image stuff that I was mentioning. So, yes, there's the concept of AI kind of in popular parlance. I think AI used to mean sentience, right? Like your computer rolls over and groans and goes, "Oh man, I'm hungry," or what have you.
Commander
but that's definitely not what we're talking about. What we're talking about is just much more sophisticated decisioning or classification technology.
Less hands-on.
Yeah, there's a lot of the idea that the algorithms are like neural nets are actually things that can be applied now. I mean, neural nets used to be extremely slow and their performance is very unpredictable. And so I do think some of the advances in technology, they're significant advances. But to a certain extent, your friend or whoever was providing feedback is right. It's all just algorithms under the hood, just like statistics is algorithms under the hood. All of these things, it's computing. It's not sentience.
Yeah.
Which is okay.
It's giant spreadsheets of data that you put in and you get a mathematical formula out of it in the end.
Well,
right?
I don't know
statistical model.
I don't know that I would say that it's like a collection of spreadsheets. That makes it sound like it's just chains of macros. That I think the technology is a little more advanced than that. But ultimately, all of those things can be described as algorithms.
So we had a question from one of our Slackers because I asked them, if they had any questions about this beforehand, because this is affecting everybody in the industry, not just managers or whatever people who are running vendor pits at cons. But somebody asked about how much data is required to properly train algorithms, and I would imagine that's is it like a two-pronged question? Like how much does it take for initial training, and then there's additional data that can help fine-tune it?
Yeah. So the training process for the models is one of the most sort of technical pieces of it. And in general, like to answer a statistical question that you're going to put to something with a hypothesis test, you can actually calculate sort of the minimum that you need. But rule of thumb is more is usually better, but how you gather your sample is fairly important.
Right.
So an example is if you So in communication systems, spam might make 85% of what is received. But however, if you feed a model almost everything being bad, it's going to start to think everything is bad. So you might actually need to oversample your good communications in order to get a really accurate model. On the other hand, in a payment system, you would expect fraud to, in a mature system, you'd expect it to max out at, somewhere between 1% and 5% if it was totally out of control. So you may need to oversample your fraud transactions so that it understands that not all the transactions are good. So it is a complicated question. But in most statistics, what's required to actually sort of come up with a statistically valid answer, it's actually usually a lot less than folks think. But it kind of depends on what the population is that you're sampling from, how you craft that sample in order to train it.
Right.
And the other thing that's sort of important is what's really important in training. The balance of the training data is important, but the quality of the data is super important. It's very important for some questions. If you're trying to get a very precise model, you need to be very certain about what your definition about what good is and what bad is, versus some things that are a little less structured questions where you're simply looking to do anomaly detection and notice that something is different. Then you may not need to do that much. You may not need to do that much training or have that much specificity. But in high performance models like fraud or spam, where you're very careful about your trade-offs between false positives and false negatives, you need to be very sort of clear when you're training the data. So you might have a good definition and a bad definition, and then there may be sort of these gray areas, and you actually need to scoop them out of the way because they'll just confuse the model if you mischaracterize them. It's either good or bad.
Right. Yeah, that was the one of the other questions was, how do you ensure the training data is clean? Or the other question was, how do you determine what causes a false positive or a negative? So
sure. So trying to determine how to cleaning the data and prepping the data is the worst part.
Really?
Nobody likes that part. I used to interview folks who were interested in doing data science work, and they were like, I really want to do machine learning. I'm like, okay, that's awesome. But the machine learning thing is like, you press a button. I mean, you write a command, you have it sent to a script, and then you press a button, and then the machine does the work. But before that, you've spent weeks trying to set up your data and make sure that it's clean, make sure that it's complete, make sure that it has the right signals associated with it. You may need to do some variable creation and such. So data quality is very important, and you do need to spend a lot of time cleaning up your data in most systems. And then the other question was, what causes a false positive versus a false negative?
How do you determine what causes a false positive or a false negative? I would assume that the algorithms are going to, make that determination on their own, and then you would tweak it, right?
Right. So I think that question gets at one of the reasons why I highly prefer working with things like statistical models, because then what's spit out of the machine learning magic, if you will, is an equation of some kind, at least initially, that you can read, because there's weights and there are variables or things that you define, so you can figure out which variables are most highly weighted, meaning most highly associated with whatever it is that you're trying to encourage or avoid.
Right. When
you use something like neural net, you tend to, at least in the training phase, it may perform better than a statistical model. It doesn't always, but that's one thing people like about things like neural nets, is that they can be very performant, but you have no idea why.
Yeah.
So because it's just, it's just sort of a black box, what comes out the other side. And then another way to kind of deal with that is whichever model or algorithm you're using in production, you can always benchmark them against each other. It's just another set of, if you've already done all the work of gathering the data and the sample and all of that, run it against a panel of algorithms and figure out which one is most performant. So there are options there.
So how does this work in does machine learning work in extremely complex scenarios? Because I was in the Navy, and I worked at a weather command, and we did numerical weather modeling. So we had millions and billions and billions of data points, and complex physics involved in chaos theory, and you took all this stuff and you put it into a supercomputer and you crunched it up, and you got possibly what is going to happen in the atmosphere in the next 48 to 72
20%
hours.
chance of rain tomorrow.
Shut your face, okay? I know what you're talking about, okay? Yeah, so I mean, for the most part, they're saying anywhere between 3 to 5 days is fairly good. Anything past 7 is butterfly wings, which is, butterfly flaps his wings and it snows instead of rains. Is machine learning being used in that area or that field of like complex, modeling of, to decide outcomes of things, or does it break down at that point and actually, other science takes over?
So that is a good question. When I think about complexity, I like to go to places like the Santa Fe Institute, which focuses specifically on complex systems, because it's like as soon as you hit complexity, like actual technical complexity, everything starts to get funny, and then you're like just on the verge of chaos,
right,
which is awesome and fun to think about. But what you're describing is I have a couple answers to your question, which is, one, computers and machine learning can be at least more precise than humans in coming up with estimates or projections about things that are very complicated, right? I mean, financial models, forecasting models can be intensely complicated, and your best bet is to go with a good model. That said, I think something that makes a lot of folks uncomfortable when they're dealing with machine learning or these algorithmic approaches is that there's still ambiguity. There's still going to be an error rate. There's still some sort of trade-off between false positives and false negatives. And we're infosec folks and we hate that.
Right.
Or maybe a better way to describe it is we're humans and we hate that. We really don't like ambiguity. We like objectivity. We like understanding that something is going to be right. And communicating the uncertainty is just not something that I think folks really love.
Yeah.
But I do think these techniques help. And that's kind of why I love them so, is that I do think they help. They're faster than humans. They can take more data into consideration at any given time. And help is always helpful.
Well, they don't necessarily have to be complex either. You could have a very, very simple algorithm. It still performs better than humans because it's unbiased.
And fast.
True.
Yeah,
you can, for example, weather to predict who knows what in certain areas. You can do the entire planet if the algorithm is simple, like measuring if it's going to be a good year in the southern part of France for wine, right? That's a very simple model to create. But to have people guess if it's going to be a good year, I mean, your error rate is going to be huge.
Yeah. Which is why they've been using computers since, the 70s to help, predict that kind of stuff. But
people still don't believe them.
Yeah. I mean, they don't believe them when they get it wrong. Every other time they're fine with it. So, I mean, that's a whole that's a psychological thing in itself. Nobody blames the weather guy until he gets the weather wrong. So, there's that.
Right.
Just all the time.
Well, see LA Story for instructive detail.
Yes. Hey, great movie, by the way. Great movie. You will have the chicken. You can have the duck. Anyway, so one of the other questions somebody asked was, this is Zoke, and he said, "Why are you trying to make Skynet and kill us all? Do you hate humanity?" What do you say to that?
I love humans.
Do you love cooking for humans?
That's what a robot would say.
Yes, exactly.
I love humans.
Well done. Well done. Okay, so I was just putting that out there because he did put that on our Slack. Good
No,
job,
I always
Zoe.
appreciate that.
Yeah. So somebody else asked, in what way do you see machine learning being used in an offensive capacity for infosec? Because I know that's not my question, but I do remember there was a story a couple of years ago where DARPA was working on like competing systems that were attempting to attack one another, and there was some defense stuff going on, and they had it was like the DARPA challenge for vehicles, but it was they were attacking one another, and they learned how to really attack each other efficiently.
Yeah, the cybersecurity grand challenge.
That's it.
Yeah.
Yep.
Yeah, that was really interesting. Actually, the program manager for that came in and spoke at O'Reilly Security last year, which was really interesting hearing him talk about how they set that up and then what the results were. Well, I think that as far as offensive techniques, that's not my bread and butter. But what I think folks are doing is they're incorporating aspects of machine learning both to facilitate or speed up their learning of how the defenses work.
Mm-hmm.
So they're trying. It's almost like they're using machine learning to try and back out what the actual logic is of the defensive systems, and then I think that they are probably using machine learning just to try and make their behaviors or attack patterns appear a little more random, because as soon as defenses become predictable, people start to game them.
Right.
And as soon as attack patterns become predictable, then folks are able to usually effectively defend against them. So you were mentioning, I think Amanda had been doing something programmatically and she got caught fairly quickly.
Mm-hmm.
And so I think that like flat automation, once detected, is usually easy to keep detecting if it's repetitive. And so you can use these different techniques to kind of like learn and figure out how you're going to evade faster.
Yeah. Okay. All right. So one of the other questions we had was, who will machine language replace and who in security? So are we going to be replacing the MSSPs of the world with, somebody from the future who, kind of like Skynet?
Yes, I believe the grand plan is that everyone will be replaced by people from the future.
I like to believe that my cats are actually going to be taking over once they get opposable thumbs.
I think cats are from the future.
Oh, did you hear that? Yeah, she heard that. Mama Kitty is much in
and actually, I just thought of something about the last question, so I'll be right back. So
okay.
One of the other places where I think machine learning has some interesting applications is in fuzzers.
Fuzzers? How so?
So that's not necessarily. I mean, fuzzers can be used in sort of a pre-offensive or in a defensive capacity, but that's sort of an interesting place where it could be applied. Okay. So I think the question was the question, what's going to happen to our tools, or what's going to happen to our industry, or what's going to happen?
Probably what jobs are in danger.
Yeah.
Do I need to start looking for something else to do?
Do I need to become a data scientist and, pour through, data?
Well, I actually think a lot of folks in security, like enterprise defenders, and obviously the folks who are sort of doing consulting and stuff, are well suited, because a lot of the folks who are doing threat analysis, for example, they're already attuned to behavior and patterns. And I think that what happens with machine learning is either there are going to be some systems where maybe there's more flexibility, and so we need to learn a little more in order to leverage those tools to get at the things that we're looking for in our data, in our systems, and our networks. Or we will have vendors will start hiring tons and tons of data scientists, and they will build those things into the tools. And it will behoove us all to be able to understand what we're looking at. I mean, if nothing else, I think that a lot of us need to kind of get up to speed so that we can actually understand product quality.
Right.
Since everything, has machine learning inside sticker on it now,
Yep.
understanding the questions to ask and being able to evaluate performance shifts a little bit. But I don't necessarily think that anything that we're doing can be replaced. It's just more along the lines of automation, right? I mean, I don't think Nmap put anyone out of work, but it automated a lot of the things that folks may have been doing manually or via scripts. And then, and we build out our toolkits from wherever they start. And that's just been a common theme for the last 20 years.
Okay. So, but it also will open up other avenues for people to get into information security, not just, if you're...
Oh, I think that's definitely true.
Yeah. So, I mean, what kind of jobs do you envision that it would be creating in the future?
Well, so machine learning is just a tool. So the types of folks who would use those tools are folks who are doing quantitative analysis. And those are, in the past, we used to call them analysts. Now we call them data scientists, but they used to be analysts. So folks who are doing analysis, it's going to be another set of tools that they can add to their toolkit to make their lives easier.
So like for risk management or something, we could, plug variables or, plug our scenarios in and find out percentage of chance this might happen, or we take all of our logs in Splunk and go, okay, we've had insider issues, or we've had so many, issues with patches of Linux. These might be things in the future that we're going to have to worry about.
Right. So yeah, I think that you are hitting on something which is that like enterprise risk heretofore has been very like framework driven, and some of these techniques offer them more of an opportunity to get into doing quantitative analysis, and I think it's going to be difficult, but yes, being able to kind of understand how to analyze dynamic systems that are in the process of being dynamic is useful, although I'm not entirely sure machine learning can be used anywhere where you're trying to do forecasting or prediction. So I could see the risk folks kind of wanting to do that. And also anywhere where our folk need to connect back to business, making business cases, clarifying performance and metrics, those types of things.
Yeah.
Because this is the type of thing that it could be a game changer.
Yeah. Do you worry that machine language is getting kind of a bad rap because of so many products that are being used that are leveraging it, and it may be considered kind of
people
a negative?
Are throwing big data around like
big
they
data,
are cyber.
All the endpoint security systems, some people see that as the bane of infosec, and it's not really helpful, but they're all touting the AI and the machine language and machine learning and all that. Do you think that we're going to have a trust issue when we start moving and using this in other or parts of infosec or risk or compliance?
Well, I kind of think cybersecurity and all software has fundamental kind of asymmetries. It makes it easy for folks to hide product quality issues by using marketing as a tool to get around actual indicators of performance. So I'm not sure that this buzzword is going to reduce the trustworthiness of products available or tools available to us any more than any other buzzwordy thing has. I mean, it's been 10 years of big data, and like 8 years of data science. True. And graphs were a big thing for a while. Now it's, then it became machine learning or behavioral analytics. And now, the newest cherry on top is AI. So I think what will happen is that you know, folks want to use the most effective tools that are available, and once we sort of gather experience with these tools, we're all going to pick our favorites. We're going to know what we're comfortable with, and the things that aren't working are going to get ditched.
Yeah.
But the history of infosec is littered with products that were hot once, but then didn't really deliver on their value, and they have sort of their historical artifacts now.
Yeah. Or they were
we'll
crap.
have really awesome t-shirts that say AI all over them.
Right. Or they were crap, and because of cons like RSA, our C levels have gotten a hold of them and think they're cool. So
yeah. I guess I do worry a little bit that there are some really useful tools and techniques in the domain, and I don't want folks who have a bad product with a tool or an integration to think that the whole thing is booty.
Mm-hmm.
Couldn't think of a good word there. But so I don't want folks to dismiss an entire category of tools just because a tool didn't meet their needs. But
right.
I think it's been here forever. These techniques have been in antivirus. They've been in sort of intrusion detection products, other endpoint products. They've been around for a long time. They're just getting repackaged and kind of shined up a little bit.
Yeah, I was thinking about that because I was like, well, we've been using kind of machine learning forever with IDS. I mean, we have, rules that it follows, and if it sees something, it blocks it. If it sees, false positive, you have to go in and tweak that, and then you get updates from the company or from whatever threat list you go to. Yara rules are added to, tweak and add things to make it work. It's just, instead of us tweaking it, the algorithm is going to be tweaking it now, right? Is that the way it's going to be working? Or we still always need to have a finger in that particular pie?
Well, I think it still works the way that you sort of described it as working, and that there are some new technologies involved that may make the overall product, if you will, smarter. But to me, it's sort of that's a constant. We're constantly upgrading and updating and adding new technology into some sort of common approaches, if you will.
Excellent. Okay. Miss Berlin, Mr. Betcher, do you have any other thoughts or questions?
All right. Your talk says behavioral economics. What does behavioral economics have to do with machine learning and AI?
You're talking about my keynote from last week?
Yes.
Yeah. Hey everyone, I gave a keynote at Bsides Las Vegas last week, and it was called Something Wicked. And so it doesn't necessarily have anything to do with them. I covered 3 topics in that talk. I covered, because the sort of talk was kind of a call to use every tool that's at our disposal in order to sort of refocus on the human outcomes and human impacts of cybersecurity. I do a lot of my work focuses on protecting end users from online threats, and which is sort of a different model than the typical enterprise IT person who's trying to sort of protect a corporation, and sometimes with the idea of sort of a firm perimeter. In my world, the people are essentially the perimeter, and they're under attack. So how do I extend my defenses to help them?
Sure.
And so the 3 tools that I brought up were around data, leveraging data as hard as we can, which would include things like behavioral analytics, machine learning, AI, applying the techniques that we were just talking about today to that. The second is sort of a design-based approach, leveraging things that we know about how humans make decisions, which is popularly called behavioral economics, but it's just sort of behavioralism. How do you design experiences and products and interactions and warnings in a way that the user, whether the user is an end user or an employee or even the IT user of a security tool, so that they are most likely to be successful, make the right decision, and be as safe as possible. And then the third thing that I explored, because I am a huge nerd, is more theoretical economics. So I'm actually working on a graduate degree, an MS in applied economics.
Nice.
And so just in digging around in micro and some of the formal classes on cost benefit analysis and sort of how public policy does analysis in order to make major policy decisions, I think I sort of put forward that I think that there's actually some models from formal economics, even though not all people are rational actors. There's things that we should look at and explore in order to get to better overall policies and better strategies for being successful defenders.
There you go, Mr. Betcher. You just got told.
Wow.
Pack at lunch, son. You just went to school.
Hopefully that answered the question.
All right.
Yes, it did.
It was a very fun talk. And if you go to the YouTube of it, skip past all of the muted part, past the part where I spill a full cup of coffee onto my laptop and the mic breaks.
Oh man.
It was actually literally awesome. They played a little House of Pain for me as I went up on stage, and then there was some technical difficulties, and then I knocked my coffee cup right on my laptop. Awesome.
It's fantastic.
Mm-hmm.
I'm sorry to hear about that. That's awesome.
That's okay. It actually really took the edge off, because once I was able to actually
all
start
downhill.
talking, I just felt very successful, and it was all just like together.
You're down
We're
here.
gonna
You
play
can
this
only
game.
go up at this point. So
Yes.
Exactly.
Yeah,
so it was all good.
Should start every talk like that or not.
yeah.
It helped with my nerves.
I thought the first time I ever do a talk, I'd come out in a cheerleader outfit and then, be like,
Oh my
after that
God,
point-
please do that.
No, I do have some nice legs. I'd have to shave though before. It'd be awful. But-
No.
I'll lend you
either
some
way.
pom-poms.
Okay. I have thought about submitting a talk on something. So yeah, eventually I'll get up the nerve to actually do so. But we'll see. So, Miss Berlin, do you have anything you'd like to ask, or any other thoughts or comments?
Not on that topic. No, I just need to make sure I track you down in October so you can sign my copy of the book.
Oh, well, you're going to be at O'Reilly Security in October, which is where I'll be. So I would like to get a signed copy of the book from the author.
There you go.
Oh, really?
She doesn't have
Do
it
an
anymore.
exchange.
She gave them all away. So, yeah. So, I mean, you, in addition to being awesome, like you are, you're also you're the chair of the O'Reilly Security Conference. How do you get that job? How do you get that gig?
Well, answer your phone, even if you don't know who's calling, I guess is the answer there. Yeah, so this is the second year of the event. It's my second year of being the external chair, meaning the sort of, there's an O'Reilly chair and there's an external chair. And it's been really exciting. I feel really grateful. I had an opportunity to help put together the agenda for a conference that I would really want to attend. I've been working in defense for a long time. So having an event where most of what's being discussed is actually around how to make defenses work better has been great. Everyone who's on the program committee is outstanding. And it's just sort of been inspiring to see what folks bring to the table when they're invited to the table. So
very nice.
Yeah, it's super exciting because you go to all the other conferences and they're mostly offensive, dropping O days. This is the new tool I created to pop this, whatever. And I always like this flip side of that. I've talked to a bunch of people that don't like the purely offensive talks. They want you to tell them how to break something, but then also how to fix it. But I love having like a solely defensive security related conference. That made me so happy when they finally came out with it.
Right.
And it dovetails so nicely with your book.
I know.
Yeah, she's done fairly decent on selling her book. I don't want to.
We're up past 2,000 now.
Shut up. Really?
Yeah.
Is that a lot?
Yeah.
I don't know. I'm not a.
I have no idea.
So. Oh, okay.
It sounds like a lot to me. I have sold 0 books, so
Okay. Well, you'll get there one day.
I just have to write a book first.
Oh, well, there is that slight prerequisite.
I know a great publisher.
Oh, wow. Yeah. So,
what animal did you get on the cover?
I got a Malaysian porcupine.
Whoa.
Which I also got as a tattoo. So
what?
Yeah.
Wait.
Yeah.
Show us.
Hold on.
Is it in a
Hold on.
PG?
I know. I know not everybody can see the video.
Yeah. Oh, there it is. Okay.
Oh my! Oh, that is so cool.
That's a nice
So
prison
I'm
ink.
just describing it. It actually looks very similar to the art on an O'Reilly book, which is always that sort of neat black and white kind of line art, which is looks really good.
Yep.
I
figured out of anything to get a tattoo of, that would be a good one. And then I'm gonna get the ISBN number underneath it somehow.
Oh wow.
That's amazing.
That's way geeky. That's way nerdy. Yeah. That's way
I know.
That's
You
awesome.
get it as a tribal tattoo around one.
Yeah,
Yeah, there
right.
Wow.
And the sequel could be the second band.
Yep.
Yes.
There you go.
So, you're going to be at the O'Reilly conference. When is that?
That is Halloween,
Okay.
spooky
Yes.
in New York City. So it is October 31st and 1st are the sessions, and then there's some training that's happening beforehand. And thank you for allowing me to shamelessly plug it. You can go online and get more details. Actually, best price is ending soon, so get on.
And
We'd love to
you
see
can use my last name as a discount.
Shut
Oh,
It's like Berlin 20, I think. You can use, I don't know what kind of discount it gives you, but
2% off.
they like emailed me yesterday. It says you should tell everybody about this, but we're also stopping the cheap price soon. So
Well, you'll still get 20% discount. It'll just be 20% more. So, you know.
right.
Yeah. So,
well, act now. And also it's at a really cool venue in Midtown Manhattan, which was really interesting because I'm used to events being in more remote locations, but it was really cool. You would want to get hotel reservations too. I recommend booking early so that you can stay at the event hotel.
yeah. Okay. So no Motel 6. It's at a pretty swanky joint. Then. Okay. Very cool.
I don't know that there are any Motel 6s in Manhattan.
Oh, you don't know. I know you.
Very swanky.
The last time I tried to find a hotel in Manhattan, I was looking at like Airbnbs for $300 a night.
Oh, wow.
That were like under someone's stairs.
I think I've seen a movie about that place.
Wow.
Yeah, no, it's helpful to have the group discount for the.
Oh yeah, definitely.
If you're not a local
Very
to
nice.
the Midtown Manhattan area.
So
So
Miss
subletting corners of my room.
Corners, by the way.
Yes.
Yeah.
You have a 5x5 foot area.
Well, that could work. I mean, in San Francisco, that's a mansion. So,
Right?
yeah.
Tell me about it.
Oh. So Miss Allie, are you going to be anywhere else other than the O'Reilly conference? Are you going to be at Derby or anything like that?
I am not going to be at Derby.
Oh.
I will be speaking at Wired Security, which is happening in London. That is in September. And then I'm going to go to Cactus Con, which is in Arizona.
I wanted to go to that.
I will be in New York for O'Reilly. And then I believe in November, I am scheduled to head to Sector in Toronto.
That's nice.
Nice.
Yes,
Mr.
I'm
Lee's
very
up there,
excited.
yeah.
I really love Toronto.
There's a lot
Don't
of
tell
security
Lee that
folks up
because I'm really trying to get him to come to O'Reilly.
there.
Why not both?
Uh,
I'm going to both.
I know, but if he knows you're going to Sector, like you're one of the draws, like how I'm going to get him to come to O'Reilly because he wants his book signed too.
Yeah.
Come to New York. Come to New York.
Yep. All right. Well, so you're going to be at a couple places, Miss Berlin? Where are you going to be at other than O'Reilly? obviously?
Let's see here. DerbyCon's next,
Yay.
and then GerCon in Grand Rapids, Michigan, and then O'Reilly Security Conference, and then probably ShmooCon after that.
Nice. Okay. Mr. Betcher, you're
Because I
just
need
going
a
to be in
break.
Austin, right? So-
2018.
Yep.
Yeah,
Dang.
The whole year.
The whole year.
coming up quick.
I want to go to Shmoo, but I don't know.
So before I drop off, I do want to let folks know that for some of the presentations that we've been talking about, the B-Sides presentation I gave last week, and also I gave a talk specifically on machine learning as relates to security. Some of that information is available online. My Twitter handle is at Selena Kyle, SELENAKYLE, and I am posting and reposting links to slides and YouTubes of some of these talks. So if you have any questions, feel free to hit me up on Twitter and or check out the links to my SlideShare and my YouTube videos and such.
Yep, we put them in our show notes. All the show notes have the links to the Something Wicked SlideShare and the other ones that you've got there, including the awesome. Velocity one as well. So cool. So we have some DerbyCon stuff we want to talk about. If you want to drop off, that's fine. If you want to head out,
I might listen for a moment.
Okay, cool. All right, so. If you have been participating in the DerbyCon CTF for a free ticket to go to DerbyCon, we're not making you pay for this. You just got to be smart enough to solve our riddles. Yeah.
And fast enough.
Fast enough,
and
yes.
Some of the people that have solved mine have done a very good job.
How many people do we have in there so far that have actually successfully done it?
Like, as far as answers go, so I had 3 flags online, and so far there's 47 answers.
Good Lord. Now, what you've got dupes though, right? We got some dupes. We have to weed through some of those. So,
well, I mean, some of the people got. I mean, a bunch of people got the correct flags, but I don't know about duplicate people with the same flags. I don't
yeah, well, I mean,
that kind of duplicate.
Yeah. So what we'll do is, if you've gotten at least one flag, and we're gonna have to find out who actually has one flag at least, we're gonna email you or Twitter you out a link to Mr. Betcher's leg of the CTF. Once you get that link and that part of the CTF, the time is ticking at that point. My leg is done and we'll go after Mr. Betcher's, and it's a puzzle that you'll have to solve. And then finally, there will be a statement that you have to pull from a challenge created by Tyler Hudak, who is at Sec Shoggoth on Twitter. He did us a heavy, and we appreciate him doing that. So the final challenge is going to be figuring out Tyler's challenge. And what you'll have to do is email bds.podcast@gmail.com with the answer. And there is an answer. And first person who gets it gets the ticket. So we gave away our last DerbyCon ticket on a charity auction. We raised $400 for Mission 22, which is a veterans organization helping against defeat, the scourge of suicides in service members. So we raised $400 for that, and we thank our winner for that. And that's already been given out, so we only have one ticket left because Miss Berlin's talks did not get accepted at DerbyCon. That must have been an oversight on the DerbyCon people's.
I think they
it was around
forgot to read them or something. Yeah.
Machine language algorithm was off or something.
Yeah, pretty much.
So, yeah, they need to tweak that. Amanda Berlin CFP equals 100% acceptance. There you go.
Yes.
Done. Mark it. Make it a thing. So
start telling the overseas cons that too. I want to get out of the States.
Yeah. So once you get the link in your Twitter or in your email, we'll try to send them all out at the same time. That way everybody's on an even playing field. It will be first person to win, and you must email bds.podcast@gmail.com, or it won't count. So if you can't follow directions, you don't deserve to win. So. Tough love, man. That's tough love.
Ouch.
That is some tough love. So, all right, Mr. Betcher, how would people get a hold of you if they wanted to?
@BetcherPound is the best way on Twitter. Yeah, DM me if you have any questions about topics on the podcast or LogMD or whatever. By the way, there is a Motel 6 at 47th and 27th.
Wow. Always finding the cheap stuff, man.
So, book it
I
down.
know what kind of neighborhood that is.
It's right by the river.
47th and 27th?
It's fine. It's fantastic.
I'm
it's
sure it's great.
20 blocks. 20 New York City blocks. So
sure, walk there.
What's that? A half hour?
Yeah, probably. 10 blocks, city blocks is a mile, I think. So anyway, so you can also be reached at @logmd, right? That's your other little thing.
Logmd.com, yes.
Yeah,
with a dash, remember.
Log-md.
Yes.
Yeah. So, Miss Amanda, how would people get a hold of you if they wanted to, discuss your book or the O'Reilly conference or the CTF or,
Either on our Slack channel or on Twitter @InfoSister, INFOSYSTIR.
Awesome. So I know it's going to bear repeating. Miss Allie can be found at Selena Kyle, SELENAKYLE, and it's in our show notes if you forget it. I'm so happy I got to meet her finally. At least not in Zoom space, not meet space. We're gonna have to figure out a time. Hey, a lot of people from San Francisco come up to Bsides Seattle. That's in like January or February. So I think it's about the time of ShmooCon. Well, never mind then.
Oh yeah, Source. There's a Source conference happening in Seattle. Too, right?
Yeah, it's in October-ish timeframe or November timeframe. Yeah.
Okay, cool. And there's also a SierraCon, the next SierraCon, which is a tiny little Risk Nerd conference. I believe it will be in Seattle next January or March, spring-ish.
Are you going to that?
So yeah, maybe.
I snuck into the one in Detroit once.
Oh, cool. That was a really cool one. I really dug Detroit. So that was really neat.
DT Dubs, yeah. Okay, so we're going to get this done with. You can follow me on Twitter at Brian Brake, BryanBrake. The official BrakeSec podcast is at BrakeSec, BRAKESEC. We have a Slack. We're very active on the Slack. We talk a lot on our Slack. There are people who are there all the time, all over the world. So if you are in Australia, India, anywhere, there's always going to be somebody on the Slack. We have at least 550 people who are on there at any one time, active.
It's a happening place.
It is awesome, and we have a lot of stuff going on there. The book club, we just finished Miss Amanda's book on the book club, so I'm actually passing that off to some of our lieutenants in the organization, the people I trust to not screw it up. And they're going to be looking at another book to do because I bit off a little more than I could chew. So I can do the podcast and the book club and the CTF club and all that other stuff, but then I find I don't have any other time in the day. So they're doing this for me, and I appreciate it. Get in there, and if you want a book specifically that you want to go over, talk to them about it. So they're going to be starting that in the next couple of weeks. Monday nights, our PowerShell class with McDouglas is going gangbusters. We've got 25 people in class, but you can still sign up for it. There's 3 sessions left, but you can either get the videos or you can wait for the videos to come out. But we've learned quite a bit in his PowerShell class. We got a job board. We got some jobs posted in the job board. We have several channels dedicated to SIM and web AppSec and DFAIR. We got a bunch of stuff in there. So join us. You can sign up at breaksec.signup.team, and our little bot will send you an invitation, and you can join us there. So that was it for this week on Breaking Down Security. If you have any thoughts, questions, or suggestions, email us at bds.podcast@gmail.com. And everyone be nice to one another, stay safe, and we'll talk to you again real soon.
Bye-bye.
Bye.
And we're clear. All right. Woo.
Yay.
All right.
Yay.
Awesome.
Thanks for
Fantastic.
inviting me on, you guys. That was fun.
No, I'm so glad you were on,
That was
and
a
I'm
blast.
I'm glad I got to meet you, and that you were able to come on and talk about this. It's one of those things that a lot of people. It's very polarizing. The idea of the machine language, and I think it's probably because there's just a lack of
Machine
real
learning.
understanding. Machine learning. I just think there's a lack of real understanding with it. So we fear what we don't understand sometimes. So
Well, and we distrust it when it keeps getting served up to us on a big plate of marketing salad.
oh yeah.
Mhm.
Oh yeah.
So
Yes,
True
we
that.
when you don't know if there's actually any intelligence used in creating it.
Wow.
yeah,
that's disgraceful.
I mean, my favorite thing to do actually when I'm wandering, well, favorite is kind of pushing it maybe, but like when I'm wandering around RSA or even Black Hat, I like to go up to, I kind of mess with them a little bit in the sense that, you know, I'm like, ooh, machine learning algorithms. That's amazing. What algorithms are they? And my friends tell me that that's not really fair because it's just a salesperson, like potentially staffing the booth. But, you know, if you're going to market and that's going to be the subhead of your headline about what your product is, what it does, and it's magic machine learning or whatever, you should at least be able to like say what kind of machine learning it is.
Yeah.
So are there named algorithms involved with machine learning on those type of products?
I mean, I would even be happy if they said something like you know, it's a state vector machine or or deep learning. You know, they don't even have to get super specific, like, oh, we're using TensorFlow and it's got 8 layers or what have you. I would just be really excited if they could kind of say something, because then when they push back, they say, oh, well, you know, it's artificial intelligence. And I'm like, okay, cool. Because I've seen a lot of folks who market what are essentially very complex decision trees, meaning a rules engine, meaning just, you know, Yara rules or whatever kind of logic statements analysts come up with, and it just chains them together. Like, is it that? Or is it, you know, is it one of these actual algorithms? So just...
You're going to make them cry. Don't do that.
Well, the first few times I did it, it was because I was legitimately curious, because I really like the statistical approaches, and I had an argument with the VP of data at my last company because he argued that the statistical techniques could also be considered machine learning. Like, okay, fine. But, you know, then tell me what it is that you're doing. I mean, usually it's something folks want to brag about. You know, they're like, oh my gosh, I'm using this Bayesian network situation and it's so groovy. If they can't get anything out past algorithm and machine learning, I don't really trust it very much.
I can almost guarantee that the data scientists or the analysts who are working for that company are not communicating that stuff to the salespeople, so they kind of have to make up their own narrative.
Sure, totally. That's totally true. And sort of tisk to their product managers for sending their poor salespeople out without like this much depth as far as to what the product is. Like I said, it's not necessarily like a nice hobby, but I do I still like to do it. And I also really believe that the algorithm itself, that isn't that big of a deal. Like anyone can leverage pretty much any algorithm. Rolling your own algorithm to a certain extent is like rolling your own crypto. It's about the training that is important, and that feedback loop that you were asking about. That's the secret sauce, and it's a lot of work. So the fact that the machine is involved, it helps, but it actually doesn't reduce any work.
Isn't rule 0 don't roll your own crypto?
It should be. If it's not, it should be the third rule of Fight Club.
Yeah. See, you've already first rule of Fight Club, man.
So anyway, well, it was a pleasure, guys. I'd be happy to come back anytime. If you get any follow-up questions in the Slack, just let me know. I'll hop on.
Yes, ma'am.
It was really cool.
Awesome.
Next time we can talk about behavioral economics.
Yes, please.
Yeah.
Yes, please.
All right.
All right.
Bye.
Y'all have a good night. Later.
Yeah.
Bye.
Talk to you guys later.